Hello everybody, this is Yakov Fein with Farata Systems. Today is lesson 17 of my series Intro to Java and Java EE. Today we are talking about Enterprise Java Beans, Intro to Enterprise Java Beans, and very brief overview of JPA Java Persistence API. So, Enterprise Java, Java EE. If you remember, you had different clients, or you can possibly have different clients in Java, or maybe thin clients in HTML. Then you have a presentation tier. In the presentation tier, if it's a web application, of course. And then you have a servlet container, which can run different things such as Servlet, JSPs, Java server faces. And the business logic is recommended to write in a separate tier, separate layer, business tier. In the world of Java EE, this business tier is implemented as EJB container. EJB container. This diagram basically shows you that the clients access the server side through the presentation tier. This doesn't have to be the case, and the Java application can talk directly to business tier. Also, all business logic can be here, and then these business classes or Enterprise Java Beans will talk to the data tier. Data tier could be relational database, NoSQL database, messaging maybe some web service, maybe a file, anything. Anything, it's up to you. Now, there is something interesting over here on this diagram. Enterprise Java Beans can live not only in the business tier, in the EJB container, but also can be packaged inside the presentation tier, in the WAR file, in the web tier. And I need to mention that there are different types of packaging or distribution of Java EE. One of them is so-called full profile, full-featured installation of Java EE, which support every single spec that is included in Java EE of whatever version you use. We use Java EE 7. If you don't want all features, you can go light, so to speak. And there is a so-called web profile. In the web profile, there is also a version of EJB Enterprise Java Beans, but it doesn't support all features of Enterprise Java Beans, which may be fine for many applications. But if you are using the light version, then everything can be packaged inside the WAR file. Let's talk about EJB containers. Why do we need EJB containers in general? What's so good about them? Can't we live without them? Of course we can. Of course you can use your best friend, the operator new, and create new instances of each and every Java class as you please. But if you want to have more control environment, say instances are created for you automatically. You know how many are there. You can easily maintain a pool of instances. Maybe you want to have transaction support. So for that, EJB container is a nice house, nice home of all these beans. What are the beans? What are the EJBs, Enterprise Java Beans? They are POJOs, plain old Java objects. This was not the case. I remember in year 2000 when I was working with EJBs, version 1.0, it was tough. If you could pass an job interview on EJB, you were considered guru. Not anymore. It's very simple and easy. But the thing is that because it was so difficult back then, people started to look for alternatives, and in particular, the most popular framework, third-party framework called Spring, was created 10 years ago, maybe even a little bit more. Why? Because people went crazy with EJBs. It was not that easy. Then Sun Microsystem and eventually Oracle, of course, they do their best, whatever they can, to simplify working with the EJBs. And they did excellent job in making it simple, but as they say, you have only one chance to make first impression. So it's very difficult for people who left EJB many years ago to come back to them because they are easier. But I like them. I think they are very useful component of Java EE. So let's quickly run through this slide. No need to manually program multi-threading. True. You can have a bunch of instances in the container, the same business instances, say transfer money from one account to the other, or maybe do some processing for the shipment, or maybe place a trade, whatever. It's a business place to write your business code. So how many instances should be created? How many will be available at any given time? How many simultaneous users can work with them? All that will be taken care of by the EJB container. Can you work with pooled database connection? Sure. Support transaction? Yes. Support message-driven beans. This is something from the MOM domain, so to speak. Last lesson was about messaging, right? And you learn how to create Java classes that can retrieve messages from queues or topics. But it's even easier if you want to use MDB, message-driven beans. You will configure this bean using annotation, and you'll say, go and listen to that queue or to that topic. Done. The rest is similar. You have message listener on message, method callback, and very easy to configure. I'll show you a sample code. What are the types of EJBs? Two major types. If I would be recording this video again 12 years ago, 13 years ago, I would say three types. We had their entity beans as well. Not anymore. No more. JPA is a replacement for entity beans, for that specific way of creating classes that represent data stored somewhere. For now, two types, session beans and message-driven beans. Session beans in turn have some subtypes, and we'll talk about it. But for now, just remember, just two types. That's all. Session beans. Session beans can be stateless or stateful, and there is something special called a singleton session bean. Let's go one by one. Stateless, as you can guess, there's no state. They don't remember state. If you have a business process that requires calling one method, second method, third method, and you want to treat these methods or maybe actions within the same method as one logical unit of work, why do I say that? Forget it. Yeah, I was trying to mix into the conversation transaction. Let's not do that. Stateless. So you make one method call. It calculated something. If there is an intermediate calculations of anything, something, then you may need to store it somewhere for the next method to use these intermediate calculations, right? Intermediate results. Stateless don't allow you to do this. Make a method call on a bean, the method finished, done. No class variables. There is no place, and actually EJB container will ignore even if you will put class variables. There is no way to remember state. You make another call on the session bean. Maybe you think it's the session bean, say shipment bean. You make a first call, you make a second call. You may not even get the same instance of the session bean. Container may be allocated for you an instance of one bean, shipment bean, for the first method call, and in between the first and the second call, someone else, some other user wanted to grab this bean, so the container gave it to someone else, and you get another instance. But since these beans are stateless, who cares? We don't remember anything between the method calls. Which is not the case with stateful beans. Stateful is glued to the user. If I am a user, I make a request to a stateful session bean, then it's mine. For how long? Until the session lasts. How to finish the session I'll explain a bit later. But the point is that this bean is allocated to me, and if I need to make a sequence of method calls on that bean, they all will be made on the same instance of the bean. Container will take care of that. Of course, you can guess that it's much easier on the container, on the server, if you will go only with what? With stateless session beans. From the concurrency perspective, of course, they are not taking that many resources. They operate for a short time per user, and then they go to another user, and so on. Stateful are allocated to the user, right? So there is a limited memory in EJB container, and if you have tons of users, how can the container possibly allocate so much memory for so much request? There is a special mechanism in the EJB container called passivation activation. So EJB container may passivate the stateful. Remember, stateful, not stateless. Stateful bean and store it somewhere on disk, while to free memory for some other users. And then when this instance particularly is needed again, it'll be activated again in memory. So there is a process called EJB passivation and activation. It's applicable only for session beans, of course. It stores state on disk if it needs to free some memory. And finally, singleton beans. Most of you most likely know what is a singleton design pattern. If you don't, please read. Basically, it's a design pattern that shows how to create an instance of a class and make sure that only one instance exists of this class. One per application. You can treat it or think about it as like an intermediate storage. One class put something in there, the other class got something from there, maybe put something else, like a place where multiple other objects can reuse. And if you want it to be the only place, you mark this class as singleton. By the way, all these words technically are annotations. At stateless, at stateful, at singleton. You create simple POJOs and you mark them with annotations. How do you package applications with EJBs? If you remember these WAR files, right? They are from web application tier. When you create a servlet or a web application, web module, so to speak, you can compress it into a WAR file. So all multiple classes will be sitting there. I hope you remember. If you don't remember, watch my video on servlets. I remember there is a structure of the directory, web.inf, meta.inf. Under web you have classes, lib, and so on. So structure for the WAR file. But if you are planning to use enterprise Java Bean, you have a choice. If you will be using the light version of EJB, you can still dump them inside the WAR file. If you want to use full featured version of EJB application, you use so-called EAR. It's also the same format, basically, archive. But extension of this file will be EAR, Enterprise Archive. EAR can include WAR files as well. So if you are starting to build big enterprise application, you create a project, or maybe, well, in this course we are using Eclipse IDE. So in Eclipse IDE you also can create a project, which is Enterprise Archive, Enterprise Project, which can build into an EAR file. Also, you can say, I also want to put inside of that EAR file some WAR files. So you can have an enterprise project which will have business tier and web tier, possibly. And this web tier you may want to put inside the EAR file. So things get a little bit messy. Not that messy, but something to consider. The EJB themselves can be packaged inside the jar file. If you are using the EJB Lite version, then you can create a WAR file and link the WAR file to an external jar file with EJBs. Or you can take the jar file with EJBs and put them under webinf/lib folder where all jars are sitting, and then build a WAR file which will include the jar file. Different options. Since we talk about this, let me just for a second go to Eclipse. If you'd be creating a new enterprise project, you can do this: file, new, enterprise application project. You would give it a name. Of course, you would give it a runtime where you want to deploy it, right? And it would build it's capable of building an EAR file. You are saying, I am planning to build enterprise project and I'm going to be using EJBs in there. If you'd be creating dynamic web projects, which we already did, file, new, dynamic web project, it's for web application, right? You create everything like we did, plus you would specify the target runtime, but we never touched this part of this window. Add a project to an EAR file. If I would plan to build a WAR file that would be included in the EAR file, I can check this box. Okay, going back. Hello World. What can be better than Hello World application? Hello World Bean. How can you create a class and make it an EJB? There is nothing easier than this. Public class Hello World, and it has one method, say hello, which returns a string Hello World. Look at this. You marked it with annotation stateless. That's all. That's all it takes to make a regular Pojo to turn it into an EJB. Who can access this EJB? Whoever. What do you need to know to access an EJB? Who remembers the last lesson? JNDI, right? If you want to access an EJB remotely, there is somewhere a container and you're sitting somewhere else. By you, I mean JVM, maybe. Different one. Then you make a remote call to that server, application server, where you deployed your application with EJB, and you make a lookup, right? You get a reference to the root of the JNDI tree, and then you make a lookup and you find the EJB by name. Then you can call methods on that bean. If you are writing a client that will be deployed in the same JVM, basically under the same application server, it's not going to be a remote client. For example, a servlet, right? A servlet can serve as a client to an EJB. And I'll show you an application like this. If that's the case, you can mark this bean with one extra annotation saying it's going to be a local bean. It's only going to have local clients. So you can use the other annotation local bean as well. Now, if EJB is a Pojo, regular Java class can implement interfaces, right? So interfaces that you will be implementing in your classes can also be marked with annotation, local and remote. Again, if you are planning to use EJB remotely, then interfaces must implement a remote interface. Now let's look at the code. Say this is a servlet and we want the servlet to be a client of EJB. Let me go real quick into our picture. See, say we have an HTML client that makes a request to a presentation tier where you have your servlet. The servlet just receives the request from the client and sends the responses back. Minimum or no logic at all. Where is the logic? Logic is sitting in this tier, in the business tier in the EJB. So in this case, you got a request, find me all the book written by Yakov Fein. As you know, one of the best writers of technical books in Java domain. So you make a call to a servlet, and then the servlet makes a call to an EJB. So HTML page, see, it serves as a client to the servlet, and in turn, the servlet serves as a client to the EJB, right? So that's exactly the case which I am looking at now. The servlet as a client of an EJB. HelloWorld Servlet. This is a class. I remember, who still remembers what are the servlets? It's a regular POJO. Extends. I cannot say POJO because it has to extend the HTTP servlet. Then you annotate it with slash whatever. In my case, I said if the URL will include this particular phrase, HelloWorld Servlet, then the servlet container will direct the request over here. Next, if the servlet is called using HTTP GET method, then the request would wind up here in the do get in the servlet. Just a reminder, refresher of the old materials. How do we find a reference to the EJB? Say we also written in the Hello World bean somewhere. If we are remote client, then the only options we have is JNDI, right? So these strike through font lines, crossed out lines, it's a valid way to look up the instance for the bean. You can do it, no problem. The other way, or the alternative, if you are sitting in the same application server as JVM, then you can do a resource injection, right? So if the servlet and EJB sitting in the same instance where the JNDI tree is, JNDI doesn't inject, of course, but Java EE can inject the reference to the instance of the bean right into the variable with the special annotation EJB for resource injection for the bean. So no lookup, and no need to call the new operator. It's done. And then you use it somewhere in your code. So in do get, so you get a reference to the IO stream for the response object, so you can send back stuff to the client, to the browser. And then over here, I make a call to the EJB, right? Into that tier, and I call say hello. Whatever that method will return will be directed to the browser where user is sitting and will be greeted nicely, as nice as the say hello can. Hands on, time to do the walkthrough. Download the code from lesson 32 from the textbook site. Unzip it into a folder. In Eclipse, create a new dynamic project. I want to name it like this. Why? They just want it like this. So you will create a new dynamic web project, and then you will copy the content of the src directory from the downloaded sample from the book into the src directory from the Eclipse project. That's what I want to do. So you to do, actually. I already did this, but if I were you to start everything from scratch, I would say new dynamic web project, give it a name, of course, target runtime, don't forget about your Glassfish 4 and so on, and finish. I already did that, and I did copy into the src folder, the Java resources was empty in the beginning. It was a new project, right? So I took the src folder from there, from the unzipped version of the sample from the book, and I copied it here. So this is how it's supposed to look like. This servlet will serve as a client for what? For the bean, for the EJB that is sitting in different package. And after you've done that, you need to deploy this project under your Glassfish instance. Right click, add, remove, servlet EJB, add, and finish. This is how you deploy the Eclipse project, dynamic web project, under your Glassfish server. As you can see, I am operating within Dynamic Web Project only. I don't create enterprise application project. Why? Because I'm using light version of the beans. And I want to package everything inside this web module. So the Glassfish is started. And as you can see, if you look at the console, you see in particular that it deployed, the Glassfish deployed the bean, hello world bean. And also it prints for us. It prints for us the lookup string. If you are planning to do a JNDI, it shows you where exactly it is. Anyway, deployed, up and running. Let's look at the code. This is the client, the servlet. I want the servlet to use the bean. The client is the servlet. What do we have? Do get. Lines 40 and 41. It does a lookup of the bean. And I want to show you the first problem. The first problem is that the bean was deployed under the server just like this. See this name? I ask you to create a project Servlet EJB, but the book that you downloaded has something else in there. So take a guess. What's gonna happen now? You got it. The bean will not be found, right? Because there's no such thing. But there is this thing. We want to make sure that we'll see that problem. Going back to the slides. Deploy the project, start Glassfish, and note for the JNDI name, we did that. Run hello world server. And there is no message, no output, and no error message. Let's see if this is the case. Is the server running? Yes. Running servlet. Run on server. Glassfish, yes. Excellent. Nothing. This little guy doesn't return me anything. Where are the errors? Maybe they are in the console of Eclipse. No errors. Nice and easy. Everything is calm. Why? Because this sample program has a bug. Right? Right. Next line. Fix the bug in line 46. Is it still line 46? Basically, the bug is, by mistake, I wrote get stack trace. Of course, it got stack trace, but I never printed it or never used it to write it into a log file. So we need to say print stack trace. At least we will see if something goes wrong. Is it line 46? It's actually line 47. Sorry, guys. I was playing with the code. So instead of get stack trace, let's do print stack trace to see what the problem, what the error. As if we don't know. We know the NDI name was wrong, but let's pretend we are stupid. Right click, run as. Always run on the servers. Nothing as expected. Do we have an error? Yeah, we do have an error. Now we have an exception. And what do we read? Severe lookup failed for this guy, right? We already know this. So we need to fix it, right? So instead of lesson 32, as I've written for you, did I? Yeah, over here. Replace lesson 32 with Servlet EJB. Over here, yes. Correct, no misspelling. Save. Let me rerun it again now. See, I make a change. Print stack trace, and the second change is the lookup name. Let me run it. Yep, now it works. See, now it responded. Now it's time for dependency injection demo. What do I mean by this? I mean, we've been doing a lookup, but I don't want to do a lookup. I want to do dependency injection instead. So we will comment out these two lines, and I ask you to print it, right? But I already have it over here. Instead of doing lookup, I want to do dependency injection. The same variable, my bean, and I am using my bean over here, right? I just want to make sure that we are using dependency injection now. Just to make sure that we are running the new version, let me do some change. Save. And we are just testing if dependency injection works now. Yep, it works with multiple columns. Everything is fine. So we successfully finished this walkthrough number 1. Moving on, stateful session beans. By the way, that hello world was stateless session bean. There is nothing to store between the methods. Just returns you the hello message. But what if you have a process and you want to store intermediate results between the data between the method in the class variable, in the bean variable? You want to save state. As in this case, you have a shopping cart, for example. You found it somewhere, and you maybe add stuff to the shopping cart, and then you keep browsing the book site or whatever, and you add another item and so on. See, each of these methods can add something to the state of this session, right? State of this bean, let me put it this way. So if this is an example from a stateful session bean, then everything will be saved. The instance of the bean is assigned to the user. And how do we know when the session ends? How can we signal to the EJB container that you're free to remove this bean? I don't need it anymore for this user. When I say remove, by the way, I mean put it back to the pool. If someone else needs the stateful bean, give it them. How to do something like this? It depends on your business, of course, of your business logic. If, for example, you have a method on that bean place order, that bean that maintains the shopping cart, then we assume that the session is over. The user added everything he wanted or she wanted to the shopping cart, and now the session can be closed. To do something like this, you need to mark the method that, based on your business logic, completes the session with annotation remove. So if I would declare a method place order somewhere in the bean, in my example, I would mark it with annotation remove. So whenever this method is called, it's a signal for the container, clean up the session, we don't need it anymore. Transactions. One of the nice things of EJB container is that it supports transactions. And as a matter of fact, if you are using so-called container managed transactions or CMT, you don't even need to do anything. Every call is done every method call, let's say, on the bean is done inside of the transaction that is automatically created for you by the container. If you want to control programmatically control when the transaction starts and how it goes, then you can work in a separate mode, in a different mode, so to speak, called bean managed transactions, which basically means that you will write an application code that will use this API, the interface user transaction, which has methods begin to open up a new transaction, commit, if based on your business logic you want to commit, and roll back. Ideally, of course, if you can live with CMT, with the container managed transaction, great. No programming at all required. As a matter of fact, I'm lying. Since your code will be inside of the transaction, the method, if the method is done without any errors, the transaction is automatically committed. right? If there is an error, what you can do, you can mark the transaction as rollback, set rollback only, I believe the name of the method. You are saying to the container something went wrong. Don't commit it. Now, transaction attribute, if you are using bean managed transactions, for example. Let's look at the case. You have two beans. One bean has some method A, and the other bean has method B. Method A invokes the method B. How to deal with transaction in this case? There are different situations, right? Maybe method A opened up a transaction using container managed transaction, or maybe manually you started a transaction in method A. Then you make a call to the method B. What if the method B fails? Should it affect your transaction from method A? Does it mean that the transaction in method A should be rolled back as well? Or maybe this method B is not that important, and even if it fails, we are fine and we can complete the transaction in method A. So there are different cases, and accordingly there are different keywords, and you can use annotations and mark each method that need to participate in transactions appropriately. For example, require new. If again you have a method A in one bean and method B, if you will mark this method B in another bean as requires new, it means that that method will be executed in the context of new transaction. Who's going to create a transaction? Container may create it for you, right? Or not supported, or never say. You don't want to bother with transaction, and don't even bother trying to do this method B in any transaction. If it fails, that's fine. Next, message-driven beans, or MDBs, messaging, right? Something that we really like and enjoy. These are very specialized beans. They are created only for retrieving messages from the queues or from topics. One important thing is that the client never accesses directly these MDBs. You can ask something like this during the tech interview. How do you access an instance of MDB? You don't. If the client just needs to drop some messages into a queue, and if there is a message bean that is listening to this queue, then this message bean will pick up the messages automatically. Message-driven beans, of course, are stateless. They don't belong to anybody. And the other important thing is that when you annotate message bean, you can tell if you are listening to the topic or if you are listening to the queue. Also, you can create more than one MDB that is listening to the same queue. This way, you will create parallel processing. Sometimes you have the sender or the publisher that is pushing too many messages to the queue, and having just one instance of MDB cannot drain the queue fast enough. So you may want to have multiple beans, and of course it's done easily with simple configuration of how many instances of the bean you want to create. If you are using MDB, you don't even need to bother with creating all these JMS contexts, consumer, and so on, because you are already sitting inside the container. And this container knows where the JMS context is and is already created for you. How to create an MDB? Easy. Just annotate it with message driven, add a no argument construction to it, and make sure it's public. And of course, it's going to be implementing message listener. For example, so this is a class, my message bean, and everything above this line is annotation. The annotation message driven has different parameters. One of them is the map name, right? The name of the queue that we want to listen to. In this case, it's acknowledgement mode. How do we want to acknowledge? Remember messaging? Auto acknowledge in this case. What type of the destination it is? In this case, it's a queue, right? The rest is very similar to what we did last time in the previous lesson. Implements message listener, and you say on message. Whenever on message is called, it's a signal that our MDB retrieved or is trying to retrieve and remove a message from the queue. And do some business logic over here. And by the way, check this out. If something went wrong, what I do, I say the context. By the way, context was also injected into a variable CTX, message-driven context. If something went wrong, I'm saying set rollback only. Don't commit this transaction. It's something went wrong. In this particular context, because message-driven beans, it means leave the message inside the queue. Don't get it. What's going to happen in this message if we bounced it back into the queue? It's I just will give you a hint. Of course, you can look up and read message-oriented middleware documentation, but the idea is there will be done several attempts to retrieve the message, and if they are not successful, the message will be placed in so-called dead letter queue. So you can do a little research if you are interested in what's happening with this. That's all. Basically, the introduction to the Enterprise Java Beans is done. And now, really briefly, I want to tell you what JPA is about. Why do I do it really briefly? Because I don't like it, honestly. It's my personal opinion. I live in the United States of America, so it's a free country, and I'm free to express myself. I don't like JPA. What do I like? I like SQL. But whoever created JPA, they thought that Java developers are special creatures and they don't understand anything but Java. And they decided to create an API in Java. So Java developers, instead of writing SQL that deals with tables in a relational database management system, they would work with only Java objects. Those Java objects will be mapped to database tables. But Java developers will pretend that they don't even care about the table. They will do select from Java objects. And by the way, how this JPA was born? As I said in the beginning of this lesson, the first spec of EJB had these creatures called entity Java beans. It was complicated. They decided to replace it. Meanwhile, the whole world started to move into a different framework, which is called Hibernate, which was offering easier persistence of data. And that's why many developers started to use Spring and Hibernate in versus Java EE. Back then it was called J2EE. So Hibernate would be responsible for persisting data in some storage, and Spring Framework will be doing everything that we are doing in session beans. Business logic. Then Sun Microsystems and Oracle eventually said we can do at least as good as Hibernate, and they decided to create this JPA, and this is basically their response to Hibernate, to the world of object relational mapping frameworks, ORM. Java objects are mapped to relational database tables. Yes, we are here, we're talking about the persistence of the data. And the JPA prescribes different ways of how to work with Java classes instead of working with SQL again. Instead of SQL JDBC, you can use JPA. They came up with the JPQL language, in a way it's similar to SQL, but it's not SQL. It deals with Java classes, as I said. The other choice, if you are going with the JPA, is so-called persistence criteria API. It's even worse because you have to create a bunch of instances of the object. One instance, add to it more instances like a grape, like a tree, just to represent a query. And of course, I said, but if you don't want to do all of that, there is a place for you to use SQL as well. If I can use SQL, why bother? Why do all that? Why make my life that complicated if I can still write SQL? All right, enough critiquing. It is what it is. They have it, and you need to know it. Otherwise, you won't get that job, right? So how do you do this? You create a class, for example, Java class, that's supposed to be saved in a table, in a relational database table called employee. If your class and the table are named the same, then just write a class and mark it with an entity annotation. Then describe all the fields in the class which will be mapped to the columns in the database table. For example, you have a variable name long ID, ID of type long. You mark it, you say that this is going to be an ID, a primary key in a table, right? And maybe this ID is generated automatically. This field is called first name. You annotate it with constraints, with validation rules. It cannot be null. Remember, when you create tables in a relational database management systems, you can mark the fields like not null, right? So this is how you do it over here. You're saying not null, and in this case, we want to allow up to 10 characters in the first name. In this case, not null for the last name, and at least the last name has to have 2 characters and not more than 20. If you have a field on the Java class, on this entity class, that has a different name, not the same as the name in the database table, then you can map them. You can say the variable manager name is actually work with the table with a column name called boss underscore name, and so on. You can define relations between, say, an employee and addresses. Based on this code, I can see that there is some class called address. One employee can have more than one address, right? So you specify that we have in one-to-many relations mapped by the field employee. Not every class in Java has to correspond to a table in the database table, in the DBMS, RDBMS. You may decide that certain fields should be treated as embeddable. You can group them. You can group them somehow, and you write them, you mark them embedded. So you can create a Java class that represent certain fields only, like phone number and a model, for example, over here. Next, JPQL. If you will go through all this routine, how are you going to write queries? Let's take a look at the first example. It looks similar to SQL, but it's not SQL. It's JPQL. This select does not select from database tables, but it says there is a class employee, and I want to find a collection of manager names from all employee where the last name is equal Smith. The question is how the code will know where to get the data from. The thing is that when you created an employee entity, initially you mapped it to a table. In this case, the assumption is that the table is the same, and you will specify the parameters of the database. So it'll know JPA implementation, whatever you use, knows that you have to, it has to connect to the database, run the SQL, use JDBC, and turn it into collection of Java objects and return it to you. So you will get back the collection of Java object, a list of Java object, which meets the criteria. In this case, the instance, all these instances will have Smith in the last name. And so on. This guy would select first name and last name if these people have iPhones, and so very similar to SQL. Entity Manager is the class that exists in the JPA implementation, and this is how you use it. Again, using injection, you are sitting in the EJB container somewhere, and you are injecting this Entity Manager. And if you want to find somebody, you can use this syntax. Entity Manager has its own classes, so its own API. It has these methods like find, for example. Find me an employee which has an ID 1234. If you want it to be done inside transaction, inject the transaction. If you want to replace something, you create an instance of the class. By the way, the fact of creating an instance of the class, creating an object, means, if it's an entity class, it means that the row in a database table will be inserted. In this example, you say you are replacing the one instance, you're replacing one employee with another, or maybe Mary got married and she changed the name or something. So anyway, so this is how you save in the database and you newly created an employee. And this is how you remove some employee. Maybe you had a different record in the variable all employee. And you do all that within a transaction. Begin transaction, commit transaction. So this is how it works. There are more examples with the query of with Entity Manager. Create query, and this little addition get result list will return your result list. See, so there is some usefulness, of course, over there as well. You don't need to write JDBC code and manually loop through every result. You will get back a list of employees, list of instances of object employee, which is kind of nice. Okay, basically we are done. So let me just do a quick summary of JPA. Why did I say that I am not a big fan of JPA? Because I know SQL. I think that programmers are smart enough to learn SQL. And programmers can write often, of course, can write more fine-tuned SQL that can be more optimal for this particular relational database management system than automatically generated SQL for you. Am I right? Maybe, maybe not. But what I'd like better than trying to map a Java class to a relational database table, I like different framework, not Hibernate. I like framework like MyBetis, for example. MyBetis framework, it used to be called iBetis, now it's MyBetis. It allows you to write SQL the way you want. You write annotation in front of the class methods or with SQL that you want to execute, and you map a Java class to the result set. Important, not to the table, but to the result set of the SQL that you wrote. It saves your time, MyBetis, by generating all this required code and sparing you from writing JDBC. So if I would have to select, I would not select JPA, but I would select a framework like MyBetis, for example. But I still recommend you to learn Hibernate. Why? Because this is what is required on the market, and don't be too smart. Don't oversmart the market. Learn what they want. And then you will decide if you want to use it or not. So what's the homework? Complete the assignment from lesson 32. And additional reading. I put you a bunch of reference points in the Oracle tutorial, which is good, by the way, to different sections. Transactions, packaging for EJB, what is web profile, and implementation in Eclipse Libs. This is, by the way, one of the implementation of JPA that is included in the Glassfish, and this Eclipse link allows you to persist not only in the relational database, but in the NoSQL databases as well. I don't want to lie to you, I didn't use it, but this is what it says. This is what is in the book. See for yourself. So we are done for today. Thank you for listening. My name is Yakov Fein. I work for the company called Farada Systems, and it was lesson 17 from my Intro to Java and Java EE series. Have a nice day.